All right, and welcome back. So today we are going to be discussing further standard form, and today we're formally going to address how to graph in standard form using the intercepts. So without further ado, let's start off with a quick do now. Let's say we have the equation 2x plus 3y is equal to 12. If x is equal to 0, what is y equal to? Let me know your thoughts. All right, let's check our answer. So again, we're going to say that x is equal to 0, and we can do this in mathematics. Think back to when we had input-output tables. We would choose an x value, plug it into the equation, and get out the y value. Well, we're using that same idea here. We know x has a value of 0, so we're going to substitute in 0 for x. So we have our original equation, 2x plus 3y is equal to 12. We're going to substitute in 0 for x. So now we have 2 times 0 plus 3y is equal to 12. We know we can simplify 2 times 0. That's just 0. 0 plus 3y is really just 3y. That 0 fades out. So we're left with 3y is equal to 12. We want to isolate for y. We have 3 of them, so we have to divide both sides by 3. In doing so, we get that y is equal to 4. Awesome. Great job. This is what's going to be the foundation of graphing using the intercepts within standard form. So let's take some notes. Graphing in standard form steps. We're going to be talking about step by step how we're going to be able to graph when an equation is in standard form. The first thing, we have to make sure our equation is in standard form. Standard form is ax plus by is equal to c, where a, b, and c are integers, whole numbers. For example, 2x plus 3y is equal to 12. That's an equation, I should say, in standard form. That's actually the do now equation as well. And we could have 4x minus 8y is equal to negative 32. That's also an example of standard form. So after we do that, then, to find the x-intercept, we're going to let y equal 0. We then substitute in 0 for y and solve for the x value. We're then going to plot this coordinate point on the x-axis. It should read out the x value that you just found, comma 0. After that, we're going to find the y-intercept by letting x equal 0. Substitute 0 for x and solve for the y value, where again we're going to plot this coordinate point on the y-axis. And that coordinate point should look 0, comma, whatever value of y you just found. And then we're going to connect the 2 points by drawing our line. So those are the 4 steps that we take within standard form. Please make sure you were copying down these notes because we're going to use these in the next few problems. And we want to be able to have these out while we are practicing to reference as we go. All right, let's go through an example. In this example, again, please copy this down. We have 4x minus 6y is equal to 12. On the right-hand side, those are the steps that we just went over previously. So you don't need to copy those down again because you already should have them down. But they are there for reference as we are going through this example. So again, we have 4x minus 6y is equal to 12. Step number 1, we have to make sure this is standard form. Does it look like ax plus by equals c, where a, b, and c are integers? Yes, it does. We have 4x minus 6y. That's a subtraction sign, but that's okay. That's really like saying plus and negative. So we're okay. We're allowed to have a subtraction sign between the term with the x and the term with the y. And we're equal to a whole number. Awesome. So now we're going to find the x-intercept. We're going to let 0 be the y value, or y is equal to 0. So we go back to our original equation, 4x minus 6y is equal to 12. We substitute in the value of 0 for y. So now we have 4x minus 6 times 0 is equal to 12. We can simplify negative 6 times 0, and that's just 0. So we have 4x minus 0 is equal to 12. Well, 4x minus 0 is just 4x. So now we have 4 times x is equal to 12. When we want to solve for x, we have to divide both sides by 4. And thus we get that x is equal to 3. So that means that the x-intercept is going to be 3, 0. Now that we found our intercept, we can go on the x-axis. Notice how the x-axis is going from left to right. And we're going to plot 3, 0, which should look like this. Awesome. So now that we found the x-intercept, we have to find the y-intercept. So we're going to let x be equal to 0. We go back to our original equation, 4x minus 6y is equal to 12. We're going to substitute in 0 for x. So now we have 4 times 0 minus 6y is equal to 12. Well, we know 4 times 0 is 0. So we have 0 minus 6y is equal to 12. Here is where a lot of students stumble, and I really want you to be aware of this potential error. That way you don't make it. 0 minus 6y is negative 6y. The 0 fades away, but that subtraction sign, that negative sign, stays with your term. The term is negative 6y. So you need to make sure you include the negative. It is not positive 6y. It is negative 6y because 0 minus 6y is negative 6y. It's essentially saying, what's 0 minus 6? Negative 6, not positive 6. And now that we have negative 6y is equal to 12, we have to divide both sides by negative 6. And we end up with y is equal to negative 2. Therefore, our y-intercept is 0, negative 2. We can go on the y-axis, that's the up and down axis, and plot 0, negative 2. And now we're going to connect the 2 points by drawing our line. This is going to be a little bit rough, but you should definitely be using a ruler for this. Let me extend it. Call me Ed Sheeran because I'm thinking out loud, baby. All right, awesome. Now that we've gone through that one example, I'm going to ask that you try one out on your own. So in your problem, we have negative 3x plus 5y is equal to 30. Again, the steps are over to your right-hand side as well as a graph. You should have your steps copied down, and if by now you do not, you really need to copy down the steps. So please solve this on your own and resume when you are ready to check your answer. All right, so let's check your answer. Let's go through the steps again. 1, make sure your equation is in standard form. Is our equation in standard form? It is. So now we're going to find the x-intercept. Oh no, what happened? Goodness golly, Miss Molly. All right, here we go. So the x-intercept, we're going to let y equal 0. We rewrite our original equation, and we substitute in y for 0. We can simplify 5 times 0, and we get 0. So negative 3x plus 0 is just negative 3x. That's currently equal to 30. We divide both sides by negative 3. We find that x is equal to negative 10. Therefore, the x-intercept is negative 10, 0. This light blue screen shade is starting to bother me, so I'm going to click it until I get back to gray. So please, close your eyes, that way you don't get a headache. I will let you know when I'm back. Not yet. No. There we go. We're back now. We are back at the gray, so we're feeling great. All right. Someone call Mr. Gray because he's back on screen. All right. So now we're going to find the y-intercept. We're going to let x be equal to 0. We rewrite our original equation. We have negative 3x plus 5y is equal to 30. We substitute in 0 for x. Simplify. 0 plus 5y is just 5y. We have 5y is equal to 30. We have to divide both sides by 5. We end up with y being equal to 6. And our y-intercept is 0, 6. The one thing that I forgot to do here is I forgot to graph. So thank you very much for catching up on that. So we're going to plot our x-intercept at -10, 0. We're going to plot our y-intercept at 0, 6. 1, 2, 3, 4, 5, and 6. So now we're going to draw our line connecting these 2 points. Awesome. Great job with this, kiddos. Keep up the great work. Please make sure you have down those steps as we're going to use them throughout our time talking about standard form. Let me know if you have any questions, and I'll talk to you soon.